Hey, Pack Leaders is here.
Hi,
Friends are
guys.
protecting families, protecting Pack. I got Evan here. He wanted to be in the video with us. So today we're going to do an update on our programming. He doesn't know what's going on, but let's show you. Today I have this. So here is a network, not network, but list of nodes.
So, we have our credit.
And this is supposed to be 0, but right now it's appending to this list.
Hey, Dad.
It's not smart enough to check it yet, so I'll have to build in some things to be able to check if the node exists, to just update it and not keep appending new ones. I have the current position as Z, as current price.
Dad,
Hold it.
when we're done this video,
Alright, so right now I'm able to contribute and update a list of input nodes. I plan on doing something like current price, and then do like other inputs like maybe velocity, acceleration can all be added in here. Anything else I can think of, I'll just keep stacking on it without having to worry about inserting in weird places. And it'll know to pull this input node, and it'll know what to do. I have these node position X and Y based on the node number. So it's gonna kind of create the nodes based like on the Fibonacci sunflower seed. So you kind of think of sunflower seed growing, it's gonna keep sunflower. Oh, look at that! I can Google this sunflower seed Fibonacci. There you go. So as the neurons come out, the inputs is gonna kind of create like this. And then what I'm gonna do is think about a cylinder, another layer of the sunflower seeds stacked on top of each other. That'll be the hidden layer, and another one, third one, will be a the outputs. So all the inputs won't be connected to each other, but it might connect to each other. And I think I know how to do that because of activation functions and normalizing the data. So it might connect to each other, and then to create a different kind of input than which connects to the hidden nodes. Okay. So I would think about this kind of like it'll connect like, yeah, hard to explain, but I will maybe try to demonstrate better. But think about like back in the day with these old telephone switches.
Dad, can these glasses do the same as those built-in glasses?
I don't know. Here it is. Yeah, there's a good picture. So think about this node as like a database of this. And and then so they're gonna be connecting it with kind of wires that kind of pop out like that.
Bye. My mom's going.
Yep. So this input connect to this input, that input connect to that input, and that'll be kind of one wafer of inputs to kind of transfer the data, maybe create different indicators if it needs to, or indicators that I might not even know about. That would actually be kind of interesting. Inputs, indicators that I don't even know about. Allow me to create that and let it tune itself and create some inputs. And then once that's done, it'll then be able to pipe into another layer of a hidden network. And if you could kind of think about a cylinder, would be interesting. So let me see if I could kind of demonstrate this here. Okay, if you can. So we have our input layer, and it can create more inputs or indicators that, you know, on its own. I'm glad I talked to you about this. Great ideas. You helped me with that. And so once it creates these other indicators, I would then have another layer. So just imagine that this is another one of these guys, but flat. And so the inputs would then go into this hidden layer, which is also kind of like one of these guys. All right. And so the hidden layers would then be able to create from the center out, kind of like sunflower seed. They will connect to each other, and they'll wire to each other. And but then there's inputs going from here, maybe this wire going to this wire, like that kind of thing. So an input will connect to the hidden inputs, depending how I want to connect. I don't care. And then we'll have another one that then goes out to another layer that goes to output. So 1, 2, and 3. And now the hidden layer, I will allow it to have multiple hidden layers in this deck. Even though it can kind of go deep already on this plane, it can also go 3D, another layer, depending if the number of hidden layers exceeds this by 2 times. So let's say there's only 2 input layers. If I have 4 here, and that's all I have, then I will probably stack another one just to kind of, not make it too wide and ratio wise, because I don't want this to be 2 inputs and this is like 1,000 and it's like all weird. So I'm going to try to like scale it long wise to keep it the same width, and that's just for aesthetics, kind of thing. So that's what I want to build in, and then the output will go into another layer with also a sunflower seed kind of a deal. Now, I thought about maybe the hidden layer to maybe create like a brain. Let me see, a Fibonacci shell, and then we could kind of visualize this shell on it. Let's see. Let me show you this real quick. But they are saying that this kind of looks like a brain. So think about what I just said about the hidden layers. If I had those hidden layers follow that line and curve out on a Fibonacci ratio, and it's also on the brain too. So let's look at that. So Fibonacci, kind of the same thing, but kind of like, it's tight in the center, and then kind of as it gets bigger and more neurons kind of thing. And then I'll kind of space them out based on, I don't know, some other kind of Fibonacci number. Or maybe how the same way the sunflower seed is distributing, but was distributing the distance that way as we curl out. So yeah, I'm kind of excited to see, just for funsies, just to aesthetically create a brain, I guess, or who knows where it might lead to, general AI, hopefully, I don't know, and kind of create this this Fibonacci deal, and just bigger neurons as it rolls out, kind of thing. So yeah, that's where I'm at right now. So pretty excited. I'm glad I'm able to kind of get to do this kind of work. One more thing I want to talk about is that the neat documentation, the algorithm, is the white paper, is very simple, and they don't really give you all the details. So I just want to give this one tip here on that you kind of have to come up with your own stuff, basically. And they don't teach you how to do every little thing. And so just like here, I'm going to show you this picture. I'll have to zoom in on this one. The node gene, they kind of give us, there's a number there, but then they never tell us the position here because we want to plot it later, but so we have to give it that. And that's kind of where I actually store the location of the sunflower seeds based on an equation there. They don't tell us that there's a bias. They don't tell us that the activation type, and there's no value. Okay, so because of that, I kind of have to add it in there. I was like, hey, well, where's this part? Where's that part? And you kind of have to figure that out. For the connections, though, connections gene. Yeah, did it tell you put a name for the connection? No, but I thought maybe it might be useful for later. I don't know yet. I might remove it. Who knows? Innovation number is good. Weight stat is good. Input. Now, I think there's going to be an input node, but then they describe it by just a number, like input 1, input 2, input 3. It doesn't know if it's input, hidden, or whatever, but what I think it's important is that we need to have an input node and an input node type. So I know it's input or hidden or output, and an output node, hidden, input, or output. So there's two types of information, and the reason why is because the way I organized it, I didn't want to organize it as one big long list of nodes. I wanted to store it as input nodes, hidden nodes in a different folder, and output to a different folder. So you see this one here, it's going to be basically a page of all inputs, and we have to kind of stick to the standard. So whatever it creates, we can then use this standard and be able to create other variations, and then be able to mate the neurons layer. If I don't have a standard, then this could be maybe price, and then another, maybe someone else could have done it instead of node number 1 as being price. They could be node number 1 as portfolio wallet amount or something like that. And then be like, hey, well, how do I match these up? I can't, So this kind of creates the standard or the legend of how to match up these inputs, and then whatever gets created later on, we'll see how that goes. But as long as they're consistent, they use it consistently. If it means one thing, it should be meaning one thing, kind of thing. Hopefully that makes sense. That was just me rambling myself, kind of giving myself ideas, but hopefully you can pick out something here and kind of do with that. And so later on, I'm going to have to put timestamps here because as I update this time, I need to put a timestamp of when I updated this price, but then also a check-in and check-out system, a library system, so that any computer can look at, oh, you know, computer one is working on this node and he's got a bigger list, and then I have a second computer that goes, oh, you know what, this is expired. Let's go ahead and work on it. I can check it in, check it out. And I have multiple computers working on this simultaneously, asynchronously, with a check-in, check-out, kind of like a library book system. So he's going to say, I checked it out, write his name in there. And then once he's done with it, release his name, take it out and say, okay, it's available for anyone. If the timestamp expires, go ahead and work on it. Check it in, check it out. Then double check it again. Make sure that no one else has checked it when you checked it, et cetera, kind of system. All right. I think that's all I have for today. This is probably going to take maybe, I'm still estimating maybe by June I could have something working. It looks like it's a pretty straightforward neural network because it's like simplified. And I can really make it real simplified because with the power of laziness, I want to do less. And so I was like, dude, why am I going to create these inputs and why don't I just stick a camera there and maybe some sound that can watch and listen. Oh, that's for like a robot layer, but just maybe watch and then just do convolutions on it so they can pull out whatever it sees on Bybit. And then the output is just mouse movements and keyboard, and that's it. And I don't care if it's like, you know, buy, sell, limit, you know, I'll let it type in this number. I'll let it click whatever it needs to click. And then, you know, then I was like, how do I teach it to perform? Like, I don't know. Like, hey, will you please do well today? I don't know. And, you know, you can listen to me and I can talk to it. And, you know, and I think that's what general AI might be, is you have to really simplify. And I think the more narrow we are in telling it what to do, like micromanaging things, the less of a general AI you have. And so the less micromanagement that you put into it, the more character it has to have in order to have its own thing. So I kind of think about how you have some bad apples and some good apples, and maybe they just got brought up a certain way, and maybe some people got brought up a better way, you know, or maybe some people just had a bad dice rolled on them. I don't know. And so it's just how you learn from your experience. And there's going to be some relearning there. So once I learn something with this neural network, you ever remember like you did something like and you made a mistake like on a sports game, like, oh man, how did I miss that shot? And you kind of think back like, hey, if I dribble this way instead, if I remember this guy likes to do whatever, and I dribble across my leg instead of what I did, and you kind of basically reminisce, I guess, or remember what you did. You kind of go back and backtrack, and you're optimizing and learning from your mistakes. And then after you learn from your mistakes, you kind of like update those neurons for a better scenario where you actually make the shot, and you kind of update it to the master node, master or whatever, and then learning from there, and then propagate it. So I think the never stop learning. I think that's what I kind of is the standard, or the philosophy, or you want to call it, of never stop learning is the way to get to general AI, where you can never stop learning much faster, run more scenarios. And you think about it, you're visualizing it, and you're like, yeah, I visualize a scenario, and I think that works. But if the computer stops there, then that's all kind of it, right? But what do you never stop learning after you got this? Well, maybe I can do better. Maybe I can do better. Maybe I can do better. And you can run a whole lot more and get better scenarios, and then do a better job. And you just keep mastering, being a master by spending more time on it, practicing over and over. And I think computers can do it that way better than us, and with less time, right? And I think with that, collectively, we'll definitely get to general AI a lot faster. But there's a lot of stuff going on. And I mean, this is just my first 6 months. What do I know? Who knows? There's probably way more out there. We'll see how this goes. All right. Thanks for watching. I'll talk to you.